Okay, continuing from the previous slide, we have the formula flow velocity, which is a flow through the pipe, which we already got. The flow through the pipe value we got from here, 40 lpm. We converted that into this value, meter cube per second. So here, and the area of the pipe bore, we got the area of the pipe bore by using this formula, pi r square or pi over 4 d square. We got that value, and then this value we can just put it in this equation. Oops. So we have the flow through the pipe value, which was 40 times 10 to the minus 3 over 60. So you can keep that value just to make sure you do not round off whatever answer we could get. Let me just put the answer. So that will give you the value 6.66, 6.6 recurring times 10 to the minus 4 meter cube per second. That's and the area we get from this one. We will get the area. The reason there's a millimeter square and that's 10 to the minus 6, because we need to know 1 millimeter square is 10 to the power of minus 6 meter square. And then we put the values here on this formula and that value here. When you put in the calculator, you will get this flow velocity 3.77. Now, it's quite important to find the wall thickness of the pipe is suitable that can withstand the working pressure. If not, the bulging will happen, the pipe failure will happen, and so on. Let's move on to the next one. When we do the pump selections, we need to make sure certain parameters, certain variables are checked and measured across the performance. We look at the maximum operating pressure. What is the operating pressure of the pump? What is the maximum delivery of the pump? What type of control is there? We also need to find out the speed. What is the pump drive speed? And we need to find out the type of the fluid, the density of the fluid, viscosity of the fluid, and the other characteristic of the fluid. We need to find out the pump contamination tolerance. Some pumps, they can accept a lot of contamination and it does not affect their efficiency. Some pumps, if you change you add the foreign bodies, it just change the efficiencies. It can result in clogging as well. Now the pump noise level, it's also measured. The pump noise level number 7 is linked to the drive speed, the type of the fluid, and the contamination. Depends on where you are putting the pump. We need to consider the shape and the size, geometry, and the weight of the pump as well. How would you like the efficiency of the pump? Like, would you like a lot, less? Depends. Is the efficiency a really important criteria? Some places the efficiency is very important, where you're relying on that specific pump to deliver all the output. Where the weight is a factor, where you cannot put multiple efficiencies. Again, then there's a cost. Cost is a most important factor as well. The other one is suitability. Is that available? Can I change it with another system? Is there compatibility as well? So if there is no compatibility of that pump for a specific system, we are not going to actually put that pump in place, because it's not going to simply work. Then we also look for maintenance and spares. Like, can we maintain the pump? Is the spare parts available? It's exactly like some companies, they manufacture a pump and everything, and then later on, after like few years, they stop making the specific parts and it's not there at all. So then if someone has that pump, he cannot buy the original spare parts, and hence it's not viable. Okay, now let's have a look at the maximum operating pressure. Maximum operating pressure is determined by the power requirement of the circuit, of the hydraulic circuit. It's also depend on the application. It depends on the availability of the component. It depends on the type of the fluid, and at some extent to the environmental level of the labor, both using and maintaining the pumps. Now, in general, higher the operating pressure, the higher the component cost, the lower the choice of the components are. Now, why would we like to use select a pump with a maximum operating pressure? Why? What's the advantage of that one? The main advantage is of higher working pressure is a reduction in the fluid flow rate for a given system power, because it will have higher efficiency, resulting in smaller pumps, smaller bore diameters, and smaller components. The disadvantage is that at higher working pressure, the compatibility of the fluid can have an adverse effect, where precision control is required over a different variation of the load, so that the pump it will have an adverse effect on the precision. So we need to just manage the balance between the advantages and disadvantages. Usually we prefer, let's say, increased operating pressures, which mean higher cost. Now, maximum pressure for few applications are given in that table. So if you're looking at machine tool, the pressure is around 200 bar, the units are bar. If you're looking at mechanical handling, 250. If you're looking at the mobile application, 300. Press work, it's around 800 bar. Now, the operating pressure of the pump depends on the fluid used. So what type of fluid we are using. The fire resistant fluid is generally not as a good lubricant as a mineral oil. So if you want a pump to have a certain life expectancy, if you're using a fire resistance fluid, it will decrease. The maximum operating pressure will reduce, and it's better to consult the manufacturing guide. Now, then we got the maximum operating pressure and the range of flow rate. I will show you a table. Now, this is a maximum operating pressure. So different types of pumps here, external gear, maximum pressure from 40 to all the way to 300. Now the delivery in liters per minute is from quarter of a liter to 760 liters. Now assuming this is water speed, all the way from 500 to 3000. Now minimum filtration requirement is 100 micrometer. That is a micrometer symbol. Pulsation, it provides a high pulsation. If the pulsation is high, the noise level in decibel is going to be high as well. And the efficiencies is between 70 to 90. That's high efficiencies. If we have a look at the radial pump, the pressure is quite a lot, 350 to 1720. Maximum delivery is all the way up to 1000 liters per minute. The speed is to 2000. Filtration requirement is a little bit less than that. Pulsation is high, but it gives you quite a good efficiency, and again noise level is high as well. Okay. Now, whatever pump you select, you need to make sure that it is able to deliver the maximum flow rate as required by the hydraulic circuit. If it is a hydraulic circuit and the demand is constant, a fixed displacement pump is chosen. When the demand is at a series of fixed level, a multi-pump system is used. Now, what I mean by that, for example, now they want in the morning they want a certain flow rate, and then after at 10 o'clock, 12 o'clock, the flow rate they want more flow rate, and then later on in the evening they want a very high flow rate. So then what we do is we use a multi-pump system where we can turn on multiple pumps to provide a different flow rates. For demand, which varies within a relatively narrow band, a variable displacement pump is used. If there is a wide variance in the system demand, and we put an accumulator circuit which satisfy the requirement. Now, the pump capabilities and abilities, efficiencies, they are stated by the manufacturer for a specific fluid, for with different viscosity, particular viscosity fluid, at a different pressure, at different temperature. If you increase the temperature, there will be reduction in viscosity. So when you buy an engine fuel, WD-40, so not WD, 5W40, now 5W100, 10W. The first one give you the viscosity at low temperature, at -30 temperature. The top one give you the viscosity at high temperature. Now, it does not matter, because when the fluid is inside the engine temperature is high. So it does not matter, but it matters what is the viscosity at low temperature. If you put that fluid, like which has a high viscosity at low temperature, maybe if you take that car to Antarctica, it might turn into a solid. Viscosity will be so high, it's not going to lubricate. So the top limit of the viscosity remain the same for the engine oil. Okay. If you increase the temperature, the viscosity decreases, but the pressure increases. Now, if there is an increase in the pressure, it can result in the leakage across the pump. If there is a leakage, then it will reduce the pump delivery. If the pump delivery is reduced, the pump efficiency is reduced. There will be more wear and tear. Now, so when we look at the pump selection criteria, we need to make sure we select a pump with a capacity of 10% higher than the required capacity to make an allowance for all these criteria. So there are different types of pumps available from 1 LPM to 1000 LPM.